Okay, hello guys and welcome to my video on the wrapper classes in Java. Just to be sure, you know we're on the intermediate learning level. I suppose you already know the basics of your OOP and you watched the data types video on the beginner learning level, so we can get going. Okay. So yeah, let's maybe do a quick recap of the data types I talked about in that video on the beginner learning level. So we can have an integer, for example, which represents a whole number. Whole num, let's say it's 320, something like that. Of course, we can also have a double, so it's a fractional number. We could give it a value of 32.10. Of course, but I don't want to type out so much, so I'll skip I call them sub data types of integers. This is an informal way of speaking, of course, but I think you know what I mean. Talk about the byte, short, long stuff. Also, we don't talk about the float stuff right here. We also have a boolean, bool true, for example. So this the boolean simply is the truth value. This variable can only hold the truth value, it's the true or false. Yeah. Then we also have a character, jar symbol, for example. And remember in single quotes. So by the hashtag here, for example. And yeah. And now let's also do a recap on the distinction between primitive, what I called primitive, versus complex data types. Yeah, and I think you shouldn't talk about complex data types. You should rather speak of data structures. Yeah, I talked about this in the variables and data types video I already uploaded. But of course, these are just it's just I don't know, it's a semantical issue. We don't have to bad because we have to have an intuitive understanding of what we are trying to differentiate. Okay, and what we are trying to differentiate. Okay, there's an integer. Okay, and in a way, an integer is like an atom. It's like a primitive data type. And in my lingo, a primitive data type just is a data type, okay? Because it isn't a complex data type, okay? And then of course the question becomes, what is a complex data type? And I gave you in the other video, I gave the example of a string, which is a very basic complex type, okay? So we could call this a string example. Hello world, for example. And of course this is a complex data type because it contains. I'm not speaking here about how this stuff is actually implemented in Java. I speak about it on a conceptual level, okay? This is a complex data type in the sense that it's a collection of a more primitive data type and it's a collection of characters. In the end, a string is always a sort of list, you could say, of simple characters, okay? And because of that, it is a sort of collection, and because that's a complex data type. So complex meaning it consists of something more primitive, more elementary, okay? And in that sense, a primitive data type is something which cannot be broken down. In that sense, it's like an atom. It is the simplest basic unit of data, of the kind of data there is, okay? And as we talked about previously, there's, for example, the integer and the double, but these are primitive data types. And now let's talk about what a wrapper class is. Okay? A wrapper class, in the end, is nothing but turning a primitive data type into a complex data type. And that complex data type is what we could call, is simply an instance of the class integer.java. For the case of integer, okay, so let's say we have a primitive data type. We have a variable. Sorry, I thought somebody was knocking on the door. So what I was saying is, let's suppose we have a primitive data type integer, okay, like on this line here, and we can turn this integer into a complex data type, an instance of the class integer.java, simply by declaring integer. So for example, let's call it int object to make it clear that this is actually an object, an instance of said class that we will have a look at, equals to 3. You can say this, no problem at all. Okay, and you see here is like, syntactically speaking, these complex data types in the sense of these objects right here, okay, they are instances of classes. In that sense, they are more complex. Okay, in the end, most people don't like saying this, but I think it's actually true. For me, a class is also a complex data structure. Okay, so there are the primitive data types we talked about earlier. And then are the complex data types, and people usually think about arrays and lists. We didn't talk about this yet, so let's just say array is just a collection of integers, for example. And then they say, okay, a class is something besides that classification. Okay, so it's neither a primitive data type, nor is it a complex data type, it's just a class. Okay, but I think we couldn't just call a class a user-defined data structure, for example, and this is a fine way of speaking. And in that sense, the class integer is just what the people who actually created Java, because the integer class is in the JDK, it's in the standard library. This is simply a complex. It's a data structure they themselves defined. Now you could ask yourself, how is it actually defined? Let's have a look. And this is something really nice by just pushing command and left click on this class name right here. We can open the integer.java class file, and you can see this is a public, find class integer. we already talked about OOP, so you should understand what this means. This simply means this is final, so this class cannot be changed. Makes sense. This is internal to the Java language, so to speak. This is simply part of your language. It's public. You can access it. It's called integer. It inherits from the more general the superclass number. And you can see some interesting stuff right here. Right here, for example, there are the attributes. These are also final. Remember, we calculated the maximum value of an integer in the video on the beginner learning level. But now, for example, if we want to access this attribute, okay, static attribute, you can do it in two ways, of course. Since it's a static attribute, I would do it like this. We can simply write integer.max value. We can print it out. Shift F10. Let's run it. It's compiled, and we see we could have saved some brain power and by calculating this number, because this is also an attribute of the class integer. Of course, you could also do it like this. Let's run it. This is the same, but as you should remember, do not do this. We want to, because the max value is the same for every integer. So it's better to access this attribute via the class and not an instance of the class, because it makes no logical sense. So you should know this, because we talked about OOP a lot already. But it depends on the way I'm uploading these videos actually. So let's simply suppose I already uploaded these videos, and yeah. Okay. So you can see that, let's look at the integer class one more time. There are attributes, for example these, which are come pretty handy, but there's also of course constructor. Public integer, where you can simply pass in a value. Okay, we did this under the hood. I think what's going on is this. Let's create another object, integer int object 2. Okay, it's a weird name, but new integer 3. Okay, I think this is deprecated. We shouldn't do this, but I think this is what's going on under the hood here. So here you can see how we actually create the object. This is something which is done implicitly here. Okay, I leave it right there. I don't have to delete it. But of course there are also some functions which should only be called via the instance. For example, if we wonder system.out println, if, let's take this in object 2, and you can see by accessing the methods via the syntax you should be familiar with, we can see all the methods, dynamic methods associated with it. For example, we could ask ourselves, does this equal, obviously this is false, but let's say we don't know the value of that number, or we simply don't want to write this in the end. This is on the primitive level. This is like, yeah, it's not the same, but it's like asking is 3 2, yeah. We have this logical operator right here, but you can also do more interesting stuff. For example, you can ask int object 2 to, okay, something is not working, sorry, let's take the other object. They should be to binary. This is also a useful little trick I'm showing you. You can always do, if you're not familiar, if you forgot something, you can always just look at the class and try to find what you're looking for, just like I did here. I want this one right here, so there should be this method to binary string to, there it is, beautiful. And let's take a regular number, for example 3, and we want to create a binary string. Of course, in this case, you could always, and you should call it in this case via the class. And this is the default. Usually, I think you should call these, you should access these attributes and call these methods statically via the class. Okay. But there might be some cases, I don't know, where you can use the dynamic methods, the non-static method, because which are like associated with some object. But these functions can be very useful, of course. Let's run this. As you can see right here, this is the correct binary representation of 3. Let's say we forgot how big the size of an integer in the Java language. We could always, this is another attribute called size. Yeah, we can run this again, and it prints out 32. So just by demonstrating this, it should be pretty clear that an object of this integer class is something completely different than like declaring a variable of this primitive data type. Okay, this always being an object is a complex data type. It's a data structure in my lingo. Okay, this is simply a data type, the most simple, one of the most simple elements in programming. Okay, of course, creating these objects may have some advantage. Okay, because you simply gain additional functionality. Okay, as you can see right here, these are all the functions. They are probably useful. They can be useful in some context. If I just write it as 302 or whole num, okay, this is not an object, which you can simply see because if I type here, there is nothing here. Okay, nothing which indicates a method, of course, because this is not an object. This is a simple primitive data type. But of course, by using these repo classes, you gain some interesting information. For example, what's the max value? Of course, you should be able to compute this, and we computed this in the previous video. But you also get what's the size. You can have nice access to nice methods like to binary string, which can come in very handy. So yeah, that's what a repo class is, and there's a repo class for every single data type. So for int double boolean jar, and the syntax is always the same. The naming convention, I should say, a data type simply is a primitive data type. Okay, is spelled in lowercase like here, yeah, and the complex data type, a data structure, or in this case an object, is spelled in with uppercase. And this is simply an object. These are all classes, and we are, for example, you could also write here new. This is the same. Okay, new string. Hello world. Okay, this is absolutely the same. So here you are actually creating object, which you know simply by looking at the syntax right here. You know this is the way we create objects in Java. So the distinction should be clear right now. You can try it out yourself with different data types. For example, if we look at the bytes dot, there should be a bytes class. Bytes example. There's not. Okay. But look, you can have I'm sorry, double. This is a class, and there are also many different methods and attributes and stuff like that. You can just play around. But let's have a look at it because I'm confused. I thought there is a wrapper class around bytes. So let's ask our friend ChatGPT. Yes, there are wrapper class in Java for bytes. In Java there's no. Okay. Didn't know that. Yeah, but what about this? Okay. Yeah, I can see I somehow misspelled it. I don't know why ChatGPT doesn't consider this a wrapper class. I would consider a wrapper class. In the end, it makes no difference. It's a semantic discussion on the. So yeah. So hopefully that's clear. But there's one question you might ask. So why don't you use wrapper classes only if they give you so much nice functionality and different attributes and stuff like that? And the answer should be pretty obvious. These variables are allocated in memory space differently than these, okay? Because these get allocated on the heap. Yeah? And if you know anything about like software architecture and how a program is actually run and what's happening in memory, you know that allocating on the heap is way more costly and it's way slower. So usually we don't use these wrapper classes, okay? So in the end, it's not that important of a topic because these are allocated to the stack, to the main stack. So these are processed way more efficiently. Yeah. But for example, this is a fine example of a really useful function which you can use by simply accessing it statically via the class. So it's a useful library, a useful class. And yeah, I think that's all I'm gonna say about the topic. Thank you for listening to me, and we'll see each other, or you'll hear from me in another video. Bye bye.